Let's calculate the mass of nitrogen, N2, and hydrogen, H2, required to produce 40.0 grams of ammonia, NH3, assuming a 100% and 75% yield. Notice in this stoichiometry problem, we are looking for the reactants needed to make 40.0 grams of ammonia. I also want to practice how to solve for the 100% yield and for the lower yield, 75% in this example. I'll start with 100% yield and return to the 75% yield problem. Assuming a 100% yield to 40 grams of ammonia, I'll simply convert the 40 grams of ammonia to mass of each reactant to find the exact amount of each reactant required. Let's take a moment to discuss these processes. These steps and concepts are described in earlier videos. First, the mass of ammonia is converted to the moles of ammonia using the molar mass. Next, the moles of ammonia are converted to the moles of each reactant, respectively. Finally, the moles of nitrogen and hydrogen are converted to the mass using their respective molar masses. 32.9 grams of nitrogen and 7.11 grams of hydrogen will react to produce exactly 40.0 grams of ammonia. Now, this is assuming a 100% yield. Most reactions won't have this high efficiency. What about a 75% yield? Let's go back to our percent yield equation. I can rearrange this equation to solve for the theoretical yield. Now, we know that the actual yield is 40.0 grams. This is what we're looking for. And the percent yield is 75. Inserting our values gives us 53.3 grams of ammonia that must be produced. In other words, we need to find the amount of reactant that will give us 53.3 grams of ammonia. If the percent yield is 75%, then our actual yield will be 40.0 grams of ammonia, which is the mass that the question is asking for. Here, I start with 53.3 grams of ammonia and convert to the mass of nitrogen and hydrogen. I find that 43.8 grams of nitrogen and 9.48 grams of hydrogen are required to yield 53.3 grams of ammonia. Assuming a 75% yield, my actual yield will then be 40.0 grams.